Hi everyone, so now we are going to learn about stopping potential. So what is actually stopping potential? Stopping potential is the minimum voltage that required to stop the most energetic photoelectrons in the photoelectric effect. So how can we determine the stopping potential? So we can connect the photocell, here the photocell, to the reverse voltage, which means that the cathode of the photocell is connected to the positive terminal of supply voltage. So because in cathode, which is the part where the photoelectrons emitted, so it's more positive compared to the anode. And for anode, here the anode from the photocell is connected to the negative terminal of the voltage supply, and we know that anode is the part where receiving the electron, so here is more negative. Okay, so this one, when the light beam is incident on the surface of the cathode, the electron at the surface of the cathode will gain the photon energy and emitted as the photoelectron and attracted towards the anode. So if there is no reverse voltage, these photoelectrons will reach the anode without any obstacles or without any retarding force. But now, if we connect it to a reverse voltage, because this here anode become more negative and here has a negative terminal, so it will experience, the photoelectrons will experience a retarding force, which try to stop the photoelectron to reach the anode. So when this reverse voltage slowly increases from 0 to some value, because your voltage is increasing, the reverse voltage is increasing, means the F will start to increase, the retarding force will start to increase and try to stop the photoelectron to reach anode. Thus, these photoelectrons will become less and less photoelectrons reach anode. So fewer and fewer photoelectrons will reach anode, because now if the electron that reach anode decreases, then your current will also decreases. So when the current first reaches 0, this value that shown in the voltmeter we call as stopping voltage. So stopping voltage is where your photoelectron start not reaching the anode, means it's already totally stopped. Okay, photoelectron no motion is 0, the velocity is equal 0. So by analyzing this graph, if you look at this graph, if the voltage is positive, means you have same directions as a positive voltage, supply voltage, so there's no retarding force. So the current flow inside the circuit is always constant, because current is only depend on the number of emissions of the photoelectrons, which is depends on the frequency of the light beam. So if you have a constant frequency, means you have constant current flow. But if you reverse the voltage, so reverse the voltage means there is a current, there is a retarding force here. When you have a retarding force and your voltage slowly increases, then your current will show a slightly drop. It will drop and drop and drop until it reaches 0. So this when the current reaches 0, so this we call as a stopping voltage. Okay, so it's in the negative side because it's a reverse voltage. So what's the use of stopping potential? We know that the kinetic energy of the photoelectron is hard to measure. So by measuring the stopping potential, because stopping potential can be measured by using voltmeter, so we can use this stopping potential to determine the value for the maximum kinetic energy. So it's used to measure the maximum kinetic energy of photoelectrons. What does that mean? So your energy provided from the reverse voltage will be equal to EVS. So this energy is used to stop the kinetic energy, the maximum kinetic energy or the most energetic kinetic energy of the electron, photoelectron. So this is your Emax. So this whole energy is used to stop the most energetic electrons. So in other words, your Emax is actually equal to your EVS. So by determining your Vs, then you will know your maximum kinetic energy, because we know that Vs is very easy to determine compared to the maximum kinetic energy, because Vs can be determined by measuring the voltage across the circuit. So from the Einstein's photoelectric equation, so we have Einstein's photoelectric equation, which is equal to HF is equal to W plus Emax. So this equation now will become HF equal to W plus EVS. So from this equation, you'll notice that the Vs is actually depend on the frequency. So when we have increases in frequency, then Vs will increases. So in other words, when we have graph current versus voltage, where your F3 now is greater than F2 and greater than F1, then we will have V3 greater than V2 greater than V1. So V3 is your stopping voltage for the third frequency, and then this one is stopping voltage for F2, and this one will be the stopping voltage for F1. So when you have larger or bigger frequency, then you will have a bigger stopping voltage. Okay, now let's say we rearrange this Einstein photoelectric equations in terms of Vs, so that we can see or analyze the Vs versus F graph. So this Einstein photoelectric equations will become Vs equal to HF over E minus W over E. So from here we know that the gradient represented by this graph is actually H divided by E, while the y-intercept here is actually negative work function divided by the charge of the electrons, and the x-intercept is the threshold frequency of the photoelectric. So why is a threshold frequency? If you look at this question, this functions or this equation, so when V is equal to 0 or Vs is equal to 0, the functions will become W equal to HF. Thus, your F here is actually your threshold frequency. So that's it for your stopping potential. So the meaning of stopping potential is the energy that used to stop the most energetic photoelectrons from reaching the anode, and provided no current flow in the circuit. And this stopping potential is very useful in determining the maximum kinetic energy. So that's it for my lesson today for the stopping potential. I hope you enjoy my lesson, and see you in my next lesson.